This learning module is about pointers, the use of pointers with addresses, and call by reference, which is another method of passing arguments to functions. When you declare a variable, what happens is that memory is allocated for that variable, enough memory for the particular type of variable. If you put the ampersand sign in front of a variable name, that refers to the actual location or address in memory of the variable. For example, if we declare an integer variable named num, what that does is that sets aside a location in memory that's large enough for a variable of the type num. The way we refer to the location is with the name of the variable num. So far we haven't paid any attention to where that actually might be in memory, but that's what we're going to do now. Assume that all of the locations in memory are numbered. What we'll say for now, for the sake of argument, is that the address of this particular variable is 1278. So if we refer to ampersand num, that would be the actual address or the location of the variable, which would be 1278. A pointer variable, what we say is that it points to another location. But really what it does is it stores the address of another location of a particular type. The way you declare a pointer variable is by putting the asterisk or star in front of the variable name in the declaration. For example, if we said int num, comma, asterisk int pointer, that declares an integer variable named num and a pointer variable to an integer location named int pointer, intptr. So again, the asterisk in the declaration is what says that's a pointer variable. Now that both variables have been declared, we can store values in both of them, for example, using assignment statements. So we could say num gets the value of 3, and int pointer gets the value of the address of num. So num would now store the value 3, and int pointer would store the actual address or the location of the variable num. So for example, if the location is 1278, that's what we're storing in the pointer variable. But usually we don't know the actual number of the address of the variable, and it could be different every time we run the program. So instead of putting a number in there, what we do is we draw an arrow, and what we say is that the pointer variable points to the variable num. But again, what it's really doing is it's storing the address of the variable num. Once you have a pointer variable, the value of the pointer variable is the address. To refer to the value that's stored at that address or in that location, you do that using what's called the dereferencing operator, which is the star or the asterisk that you put in front of the variable name. For example, if I say star int pointer, that means the value in the location pointed to by int pointer. So if I assign to that the value 5, that would store the value 5 in that location. And since int pointer is pointing to the location of num, what we're actually doing here is changing the value of the variable num to be 5. It should be noted that the asterisk in front of the pointer variable name is used for two completely different reasons. In the declaration, it is what makes the variable a pointer to begin with. After the variable has been declared, it is the dereferencing operator. It means the value in the location pointed to by the pointer variable. Some terminology here. What we say is that the expression num is a direct address or reference, and star int pointer is the indirect address or reference. So what we would have now is both ampersand num and int pointer refer to the location of the variable num, and the name of the variable num and star int pointer both refer to the value that's stored in that location. Let's now talk about how pointers can be used to pass arguments to functions. First of all, let's look at an example of what is called the call by value method of passing an argument to a function. In this program, we have two variables called num1 and num2, and we're assigning values. Num1 gets the value of 4, and num2 gets the value of 7. So what that would do is that would create two locations in memory for num1 and num2. And we would be assigning to num1 the value of 4 and num2 the value of 7. And then we print those values. The value of num1 is 4 and the value of num2 is 7. Then we call this function double them. And we're passing the values of num1 and num2 to be the values of the corresponding parameters num-a and num-b. By calling the function, what happens first is that the parameters are declared. Declaring the parameters, very similarly to variables, allocates locations in memory for them. So we have these two parameters, num-a and num-b. And what happens is the value of num1 gets passed to be the value of num-a, so num-a gets the value of 4, and the value of num2 gets passed to be the value of num-b, so num-b gets the value of 7. Then in the body of the function, what we're doing is we're changing the values of these parameters. Num-a gets a value of num-a times 2, so num-a gets the value of 8. Num-b gets a value of num-b times 2, so num-b gets the value of 14. Notice that this is a void function. There is nothing returned from this function. But as soon as the function stops executing, that sends control back to main. And then when that happens, the parameters go away. So those only existed while the function was executing. So we're back in main and we print num1 and num2. Num1 is still 4 and num2 is still 7. So that is what is called the call by value method of passing arguments to functions. So a question might be, what if we actually wanted the function to change the values of the variables num1 and num2? Obviously, this call by value method doesn't work. So now let's make some subtle changes to this function and use what is called the call by reference method. So again, in the function, we're going to have, or rather in the main function, we're going to have two variables, num1 and num2. And again, we're going to initialize the variables. So in main, we have num1, and that is initialized to have the value 4. And we have num2, and that is initialized to have the value 7. And we print their values, and when we print their values, num1 is 4 and num2 is 7. Then we call the function double them, but notice that this time I'm passing the address of num1 and the address of num2. When the function call is encountered, that sends control to the function, and the first thing we do here is to declare the two parameters. Notice that we have asterisks in the declaration, which means that now num-a and num-b are pointer parameters. So when we declare num-a and num-b, those are pointers. So we're passing the address of num1 to be the value of num-a. So num-a stores the actual address of num1, but what we'll say is that it points to that location. And we're passing the address of num2 to be the value of num-b, so num-b points to that location. Then, in the body of the function, star num-a is the dereferencing operator. So that means the value in the location pointed to by num-a, which is 4. We're saying star num-a gets the value of star num-a times 2. So now star num-a gets the value of 8. Similarly, we're saying the value in the location pointed to by num-b, which is 7, times 2 is 14, and we're storing the result back in star num-b. Now again, this is a void function. There's no return statement, but when control leaves the function and goes back to main, the parameters disappear. So num-a and num-b disappear, but notice that we've changed num1 and num2, and so now when we print, the value of num1 is 8, and the value of num2 is 14. So this is what is called the call by reference method. By passing the addresses of the variables in main to pointer parameters, that allows the function to change the values of the arguments num1 and num2 back in main. Notice that in the function prototype, the types of the parameters are pointers to integer locations. Dynamic memory allocation means allocating memory while the program is executing. The function that we will use is called malloc, which is short for memory allocation. When we use this, we dynamically allocate enough space in memory for a value of a particular type. And what the malloc function does is it returns the address of the location that is allocated. So a pointer is used to store that address. Once we're finished with the space and we don't need it anymore, we can free up the space or deallocate it using the function free. Here's an example of using the functions malloc and free. In the main function, we're declaring a pointer variable IPTR. So that is going to allocate a location in memory for our pointer variable. And then we're going to use malloc to dynamically allocate enough space in memory for an integer. So that's going to dynamically allocate enough space in memory for an integer. And then we use the cast operator to force that to be an integer pointer. And we're storing the address that malloc returns in the pointer variable IPTR. So IPTR points to this location. Before, when we had a pointer variable, it gave us another way of referring to the location. Now, the only way we have of referring to this location is by following our pointer variable. The value of IPTR is the address or the location. The value in that location is star IPTR. So we could put a value in there, for example, using an assignment statement. Star IPTR gets the value of 5. And then print the value of star IPTR, which is 5. When we no longer need that location, we can free up the space, and basically that frees up that space. So we still have the pointer variable, but it's not pointing to any location.